Your brain has a superpower it doesn't know it has. It's a quiet, invisible instinct that runs your entire life. It's so fundamental, you use it thousands of times a day without even noticing. It's the reason you look at this, a simple glass, sitting on a simple table, and know, with absolute certainty, that with one simple nudge that will happen. That feeling, right there. That intuitive leap from A to B. That is the bedrock of reality as we know it. We call it cause and effect. It is the engine of logic, the currency of science, the root of blame and praise, and the blueprint we use to build the future. But what if I told you that this bedrock is actually quicksand? That the deeper we dig into the architecture of the universe, the more this fundamental law fractures, blurs, and breaks down. That at the quantum level, before and after can become so scrambled they lose their meaning, and that the one-way street of time you live on might just be a grand, persistent, cosmic illusion. Today, we are doing more than a science video. We are putting our most trusted instinct on trial. We are going to stress test the idea of cause, from your kitchen table all the way to the absolute edge of reality. Is causality the ultimate, unbreakable law of the universe, or is it just the world's most useful, and most convincing, lie? Let's begin where we all live, in the land of common sense and everyday actions. The world you and I navigate is built on a simple, powerful promise, the promise of intervention. Our intuition, honed over millions of years of evolution, tells us that causality is all about control. If I do X, then Y changes. I flip the switch, the light comes on. I push the door, it opens. It's so simple, so automatic, we barely even think about it. But decades ago, the legendary computer scientist and philosopher Judea Pearl took a hard look at this simple intuition and discovered it was anything but. He saw that our casual understanding is actually a deeply sophisticated, three-level system. He called it the ladder of causation, and climbing it is the story of all intelligence, from the simplest animal to the most advanced AI, to you, right now, making sense of the world. The very first rung on this ladder, the ground floor of understanding, is seeing. This is the level of association, of observation. It's about noticing raw patterns. You look outside your window, you see dark clouds, and a little while later you see rain. You hear a rooster crow, and you see the sun rise. For a baby, or a simple machine learning algorithm, this is the entire world. Clouds and rain are just things that tend to show up together. Roosters and sunrises are cosmic buddies. And let's be clear, seeing is powerful. It's the basis of prediction. If you see clouds, you might predict rain and grab an umbrella. Wall Street algorithms see a certain stock pattern and predict a price jump. This rung is all about finding correlations in the data. But it has a critical, dangerous limitation: it can't tell you why. It doesn't know what's driving the pattern. It can't distinguish between a genuine cause and a mere coincidence. To get to why, you have to take a risk. You have to climb to the second, and much more powerful, rung, doing. This is the level of intervention. Experimentation. This is the moment intelligence stops being a passive observer and becomes an active participant in reality. This is where real science begins. You don't just see the clouds and the rain. You get in a plane, you seed the clouds with silver iodide, and you see if you can make it rain. You don't just notice the rooster and the sun. You put the poor rooster in a lightproof box to see if the sun still rises without his call. Spoiler, it does. Doing is about grabbing the world by the shoulders and shaking it to see what falls out. It's about forcing a change in one variable to see if, and how, it affects another. It's about asking the universe a direct, pointed question with your actions, not just your eyes. Let's make this perfectly concrete. Imagine your favorite houseplant is dying. The leaves are turning yellow. This is your observation. On rung 1, seeing, you also notice that the soil is very dry. You have a correlation: yellow leaves are associated with dry soil. A simple, pattern-matching mind might stop there. It might even conclude something ridiculous, like, the yellow leaves are causing the soil to be dry. But you are a sophisticated, rung 2 intelligence. You decide to do something. You perform an intervention. You take a watering can and you force the soil to be wet. You have now deliberately broken the old correlation. Then you observe. A week later, new leaves start to come in, and they're green. Voila! You have just performed a scientific experiment. You've isolated the cause. You didn't just passively watch your plant die, you had a conversation with it, using water as your question. This same logic is the engine of the modern world. It's behind every new drug trial, every A/B test that changes the color of a button on your favorite app. It's the simple, powerful act of a controlled, surgical strike on reality. But there is one final rung. The highest rung of the ladder is the most abstract, the most powerful, and the most uniquely human. It's the realm of imagining. This is the world of counterfactuals. This is the superpower of asking, what if? What if I hadn't watered the plant? Would it have died? What if I had used fertilizer instead of water? What if Lee Harvey Oswald's rifle had jammed? This is the realm of imagination, of creativity, of regret, and of strategic planning. It is the ability to rewind the tape of reality in your mind, change one single detail, and then play it forward to see how the story would have been different. To truly understand why something happened, you have to be able to imagine how it could have happened otherwise. This is the source of all human progress and all our deepest anxieties. This latter is why we get so easily tripped up by hidden variables, what scientists call confounders. The world is a messy place, and rarely is a single cause tied neatly to a single effect. More often, there's a hidden puppeteer pulling on multiple strings at once. A classic, textbook example: analysts look at city data and find a shocking correlation. Cities with more ice cream sales also have tragically higher rates of drowning. A wrong one: seeing intelligence sounds the alarm. Ban ice cream. It's causing people to drown. But a rung 2, doing mind asks the right question: okay, let's test this. If we were to perform an intervention, say, forcibly shut down all ice cream trucks for a month, would the rate of drownings actually fall? The obvious answer is no. Why? Because we can all effortlessly climb to rung 3, imagining, and see the invisible confounder, the hot summer sun. The heat causes people to want to cool down, leading them to buy more ice cream. It also causes more people to want to cool down by going swimming, which sadly increases the risk of drowning. The sun is the common cause, the puppeteer pulling on both strings. The ice cream was just an innocent bystander. To fight these confounders in high-stakes situations like medicine, we have invented an incredibly powerful tool, the Randomized Controlled Trial, or RCT. An RCT is a physical machine for creating a counterfactual. By randomly assigning one group of people a new drug and another group a visually identical placebo, scientists attempt to create two parallel worlds that are, on average, identical in every single respect: age, lifestyle, income, genetics, everything, except for the one variable they are testing. They are snipping all the possible hidden strings of confounding variables so they can see if this one, single string, the drug, actually moves the needle. They physically do the what-if question. So, it seems we have our answer. Causality is solid. It's about doing, testing, and imagining. It's the operating system for a world that we can, and do, control. Case closed, right? Well, what happens when we zoom out? What happens when we look at the vast, silent, cosmic processes that unfold without any help from us? Because the most obvious, the most universal causal error we experience every single day, your coffee getting cold on the table, has absolutely nothing to do with us doing anything at all. And that's where the story starts to get strange. Just take a moment and think about this. You pour a hot cup of coffee. It cools down. It never spontaneously heats up. You crack an egg to make an omelette. You will never see that egg uncook and reassemble itself into the shell. You remember what you did yesterday, but you have no memories of what you will do tomorrow. Why? Why does the great river of time in our universe seem to flow in only one direction? Why does the universe have a past that feels fixed and unchangeable, and a future that feels open and undecided? This is the arrow of time. Here is the truly mind-bending part. This relentless, one-way flow is not written into the fundamental, microscopic laws of physics that govern the universe. The deep, bedrock rules of reality, Newton's laws of motion, Maxwell's equations for electricity and magnetism, even the bizarre and wonderful Schrödinger's equation in quantum mechanics, they are almost perfectly time-symmetric. They simply do not care which way time flows. Imagine you are watching a silent video of two billiard balls colliding and bouncing off each other. If I were to play that video in reverse, you wouldn't be able to tell the difference. Both the forward and backward versions look completely plausible, because they both perfectly obey the laws of physics. The microscopic rules are a two-way street. But hang on a second. If the fundamental rules are a perfect two-way street, why is our macroscopic world a strict one-way highway with no off-ramps? The answer comes from one of the most powerful, profound, and universally misunderstood ideas in all of science: entropy. The second law of thermodynamics. You've probably heard it defined as in an isolated system, disorder or chaos always increases. But disorder is a slippery, human-centric word. A much better way to think about entropy is as a measure of probability. Specifically, it's a count of the number of invisible, microscopic ways a system can be arranged without you, a macroscopic observer, noticing a difference. Let's go back to your desk. Imagine you have a stack of 100 papers. There is exactly one way for them to be in a single, perfectly neat, alphabetized stack. Just one specific configuration. But how many ways can they be scattered in a messy pile? Billions upon trillions upon quadrillions of ways. The messy state is not more chaotic in a metaphysical sense. It's simply a state that can be achieved by an astronomically larger number of physical arrangements. The universe doesn't have a secret preference for messiness. It's not pushing your desk towards a state of disorder out of some cosmic malice. It's just that, through random jostling, the system will naturally and inevitably wander into the state with the most possible configurations. It stumbles into the most probable state, and the most probable state is what we call high entropy. Now let's apply this to your cup of coffee. The low entropy state is the very specific, highly ordered arrangement where all the fast-moving, high-energy coffee molecules are neatly contained inside the mug, and all the slow-moving, low-energy air molecules are outside in the room. As the molecules at the surface of the coffee collide with the air molecules, energy is transferred. The coffee molecules slow down a bit, and the air molecules speed up a bit. This process continues, over and over, billions of times a second. The energy spreads out, becoming more evenly distributed. The final lukewarm state is the high entropy state. Why? Because there are just astronomically, unimaginably more ways to distribute the total energy evenly between the coffee and the air than there are to have it all neatly segregated in the mug. Here's the key insight. The laws of physics do not forbid all the air molecules in your room from spontaneously conspiring, gathering up their kinetic energy, and transferring it back into your coffee to make it hot again. That is not an illegal move in the game of physics. It's just so mind-bogglingly, ridiculously unlikely that you would have to wait trillions of times the age of the universe just to have a chance of seeing it happen once. The universe, in a very real sense, is like a brand new deck of cards that was opened, in perfect numerical and suit order, at the moment of the Big Bang. That was the ultimate low-entropy state. And for the last 13.8 billion years, the universe has simply been shuffling that deck. And as anyone who has ever shuffled a deck knows, you will almost always move towards a more random, disordered, unpredictable hand. Our entire perception of cause and effect, of past and future, is built on top of this cosmic shuffle. The past is the low-entropy, ordered state we came from. The future is the high-entropy, shuffled state we are heading towards. Even your memory is a slave to this law. Creating a memory, whether it's a physical scar on your knee, an ink mark in a notebook, or a specific pattern of synaptic connections in your brain, is an entropy-increasing process. You create a tiny, localized pocket of order in your head, but the biological cost of doing so, the burning of calories, the creation of proteins, radiates a much larger amount of heat and disorder out into the universe. We are, all of us, swimmers carried along by a relentless river flowing from order to probability. Okay. So our everyday human-scale causality is about intervention, and our cosmic-scale arrow of time is a statistical law driven by probability. We seem to have two solid pillars. But what happens when we zoom out even further? What does our most profound theory of space, time, and gravity have to say about this story? This is where we must leave the kitchen table and go talk to Albert Einstein. In Einstein's revolutionary theory of relativity, he showed that space and time are not two separate things. They are not a fixed stage on which events unfold. Instead, they are a single, dynamic, four-dimensional fabric called spacetime. And this seemingly simple unification leads to a truly bizarre and deeply counterintuitive picture of reality, a concept often called the block universe. I want you to try a difficult thought experiment. Imagine all of reality, every event that has ever happened and ever will happen, from the Big Bang to the final heat death of the universe, existing simultaneously. Not as a movie that is playing out in front of you, but as a single, complete, static sculpture. Or like a finished scroll of film, with every frame already printed. Your birth, you watching this video at this exact moment, your lunch next Tuesday, the fall of the Roman Empire, it's all already there, etched as different locations within the geometry of this 4D block. In this picture, the feeling of the present moment is just a subjective illusion of our consciousness, like the beam of a flashlight moving along the scroll of film. The flow of time, from past to future, isn't real. The universe doesn't happen, it just is. I know what you're thinking. This sounds like some kind of cosmic fatalism, where free will is impossible. We'll get back to that. But for now, let's focus on the question: if everything already exists as a static whole, what on earth does cause even mean? How can an event in the past cause an event in the future if they are just two unmoving points in a giant cosmic sculpture? In relativity, causality gets a radical and beautiful rewrite. It stops being about a mechanical push-pull mechanism and starts being about the ultimate speed limit of the universe, the speed of light. Imagine you snap your fingers right now. The light and gravitational ripple from that event expands outwards from you in a sphere, traveling at the speed of light. Now, picture that process on our 4D space-time map. That expanding sphere of light forms a cone, with the tip at your present moment and the base expanding out into the future. This is your future light cone. Any event, anywhere in space-time, that falls inside that cone is a location you can, in principle, affect. You could travel there, send a message there, cause something to happen there. But any event that falls outside that light cone is absolutely, fundamentally, irrevocably untouchable by you. It is causally disconnected. Similarly, there's a past light cone, stretching backward in time, containing all the events that could have possibly influenced you, right here, right now. Anything outside that past cone, no matter how dramatic, could not have had any effect on your present moment. Causality in Einstein's world isn't a force. It's the immutable architecture of space-time itself. It's the set of ironclad rules that dictate who can talk to whom. It is the geography of influence. But even this magnificent, elegant, geometric picture starts to develop cracks at the foundation. It begins to fray at the edges when we go one level deeper still. Down into the bizarre, probabilistic, and often paradoxical world of quantum mechanics. Everything we've discussed so far, from Judea Pearl's interventions to thermodynamics' arrow of entropy to Einstein's light cones, it all still rests on a single, seemingly non-negotiable assumption: causes happen before effects. Quantum mechanics looks at that bedrock assumption, and it laughs. First on our tour of the weird is entanglement, what Einstein famously called spooky action at a distance. Imagine you create a pair of particles, like photons, that are intrinsically linked. They fly apart in opposite directions, potentially across the entire galaxy. The moment you measure a specific property of your particle, say its spin, you instantly know the corresponding property of the other particle. Instantly. It appears to violate the speed of light. Now, for decades, people thought maybe the particles were like a pair of gloves separated at birth. If you open your box and find a left-handed glove, you instantly know the other is right-handed. No spooky communication needed. But in the 1960s, a physicist named John Bell devised a brilliant mathematical test. He set up a game that classical reality, like the gloves, and quantum reality would play. The results of this game would be different depending on whether the spooky connection was real or not. For the last 50 years, we have run this experiment again and again, closing every possible loophole. And every single time, quantum mechanics wins the bet. Classical intuition loses. The spooky connection is real. Now, to be clear, you can't use this to send a faster-than-light text message. The outcome of your measurement is always random. You can't force your photon to be spin up to send a 1 or spin down to send a 0. So relativity's ultimate speed limit is safe. But our classical story that all influence must travel locally through space from point A to point B, it's in serious trouble. But it gets much, much weirder. Let's talk about the famous delayed choice experiment, first conceived by John Wheeler. In these incredible setups, you send a single photon towards a piece of apparatus. Depending on how you arrange the detectors at the end of the path, you can either ask the photon, which path did you take? Or you can ask it, did you behave like a wave and interfere with yourself? If you set up your equipment to ask the first question, you will find the photon behaved like a tiny, solid particle, taking one distinct path. If you set up to ask the second question, you find it behaved like a spread-out wave, taking all possible paths at once. Here is the absolutely terrifying part. You can wait to choose which question you ask, which experimental setup to use, until long after the photon has already passed the point where it would have had to decide whether to be a particle or a wave. It is as if your choice in the future is reaching back through time to dictate the photon's behavior in the past. Let me be very clear, this is not a time travel telephone. No information is being sent to the past. What's really breaking down here is our clunky, human narrative. Our stubborn insistence that the photon must have been either a particle or a wave all along. The universe, it seems, feels no obligation to have a single, definite history until a measurement forces the final page of the story to be written. The very notion of a clean, linear chain of events, A cause B which cause C, simply does not map onto this process. And for the final nail in the coffin of our simple, intuitive notion of causality, modern experiments have now confirmed the reality of something called indefinite causal order. Imagine you have two operations you need to perform, A and B. In our world, you either do A then B, or you do B then A. But in bizarre quantum protocols like the quantum switch, you can place a particle into a superposition of both orders at the same time. It goes through a state that is simultaneously A before B and B before A. And incredibly, certain computational tasks can only be solved if the universe processes both timelines at once. So, is that it? After all this, is causality completely gone? A total illusion? The useful lie we started with? Not quite. Something incredible happens when we zoom back out from this quantum weirdness. Very often, a clear, reliable, and predictable causal relationship emerges from the swampy, probabilistic, uncertain micro-level. This idea is called causal emergence. It's like looking at the traffic in a giant city like Tokyo. If you try to track the position and velocity of every single car, every bumper, every traffic light, the system is utter chaos, totally unpredictable. But if you zoom out and just look at the city's subway map, you see a beautifully clean, predictable, causal system. Taking the Ginza line from Shibuya to Ueno causes you to arrive at Ueno. By coarse-graining, by strategically ignoring the messy low-level details, we can find higher-level variables that have real, stable, controlling power. Causality might not be written into the fundamental code of the universe, but it emerges as the most powerful description at our human scale. So let's try to put all of these pieces together. Let's build our new, more robust model of reality. The clean, sharp, intuitive line between before and after that you feel in your bones isn't etched into the smallest gears of reality. At the fundamental level, the microscopic rules are a two-way street in time. The grand, cosmic one-way arrow of time we all feel is not a force, but a statistical consequence of a very special, highly ordered starting condition 13.8 billion years ago. It's the universe constantly, inexorably falling from its rarest possible state to its most common one. In Einstein's block universe, the very flow of time, from past to future, may just be a stubborn illusion of our perspective. And at the quantum level, the very order of events can blur into an indefinite, probabilistic superposition. And yet, causality survives. It has to. Because in the crucible of this audit, it gets redefined. Causality is not a metaphysical force pushing things forward from the past. It is about controllable information flow. That is the new definition. That is the key. If you can wiggle a variable over here, and as a result, a variable over there reliably and predictably wiggles with it, all while respecting the ultimate speed limits set by light cones and the strange probabilistic rules of the quantum realm, then you have found a causal link at your chosen scale. Causality, in the end, isn't a fundamental law of physics. It's the user interface for physics. If the deep laws of nature are the raw, incomprehensible code of the universe's kernel, then causality is the beautiful, intuitive graphical user interface that allows beings like us, who are, at our core, entropy-managing prediction machines, to get things done. It carves the world into handles we can grab and levers we can pull, so that we can try to build a future that is different, and better than the past. Your agency, your free will, isn't some magic that sits outside this system. It is a real and profound pattern inside this system. It is the demonstrable reality that within our own light cone, our choices, our interventions, our doings on the ladder of causation, are meaningful contours on the vast map of space-time. Even in the block universe, you are not a passive reader of the story. You are the pen that writes your particular sentence. When we ask what if we'd done things differently, whether in designing a new drug, shaping public policy, or reflecting on our own lives, we aren't just telling ourselves stories. We are performing the most profound and powerful act of intelligence, using a causal model of the world to imagine a different one, so that we might gain the wisdom to act, and to create it. Causality survives not as an illusion, but as our best and only tool for sculpting the future. So, tonight, when you see a simple glass of water on your table, think about the trillion possible paths those molecules could take, and the one-way street of entropy they are on. And when a memory pops into your head, see it for what it is, the physical, entropy-creating afterimage of a universe that is forever falling away from a state of impossible, perfect order. And if you want to keep auditing the deep structures of reality with us every day, questioning the fundamental ideas that shape our entire world, then do the causal thing. Intervene, and hit that subscribe button and turn on all notifications. Now I have a genuine question for you. Based on this entire journey, what's one simple cause and effect you experienced today that you might look at a little differently now? Dropping your keys? Watching a plant turn towards the sun? Making a cup of tea? Let me know in the comments below. I'm truly fascinated to see what you come up with. And if this deep dive into time, entropy, and quantum causality bent your brain into a pretzel, the video waiting for you on the end screen right now is the next logical step in this investigation. It explores what happens when these strange ideas lead to genuine, head-spinning paradoxes. Click that video, and I'll see you there.